A pleasant morning, everyone. By the way, we are going to discuss this morning about the topic on alcohols, ethers, and thiols. Okay, so if you talk about alcohols, of course, it has that functional group ending with the functional group there is R, then OH. That OH there pertains to alcohol, no? So this is now our topic all about. So the first thing that you are going to do is let us discuss how are we going to name an alcohol. Okay, so in this chapter, we are going to study first the physical, chemical properties of alcohols and ethers. So these are organic compounds that contain oxygen. It has oxygen containing compound. And we will also include the thiols. If you talk about thiols, meaning there is a presence of sulfur. And also, this is in combination, that is alcohol, not ethers, and thiols. Okay, so this is an example of an ether, of an alcohol. I mean, it is ethyl alcohol in the common name and ethanol, no? Ethanol in the IUPAC name. That is, it has a formula of this is your R and that is your OH. Therefore, this is having a functional group of ROH. R, this one, no? The group of the alkyl group, then the OH, which is its functional. What do you mean by diethyl? Diethyl ether or ether has a formula of R1 or R prime, then O, then R double prime. That R prime there could be different from your R2 prime, or they could be the same thing as what you have here. This is R prime 1 and this is R prime 2. Your R prime 1 here is ethyl, then the R prime 2 here is ethyl also. That is why, how many ethyl do you have here? It is diethyl. And the O here pertains to if it has a formula of R prime O R prime 2, this is an ether. Therefore, the name of this is diethyl ether. In the presence of sulfur, that's SH, this is the ethane, that is R, then SH. Okay. This is the ethane, and this SH here is a thiol. Alcohol is different from thiols because thiols is with the presence of sulfur. So what are the structures, the names, and the physical properties of alcohols? First is the structure. So it has a functional group of OH, that is ROH. These are bonded to tetrahedral carbon, meaning your carbon has 4. It has 4 valence, meaning it has 4 sides. Okay, tetrahedral. This one here. Okay, this is your carbon, which has bonded to 4. It has tetra, and the last function here is the OH. So this is methanol. So in a ball and stick model using Lewis structure, this is your carbon, hydrogen. This white ball here pertains to the hydrogen, hydrogen, hydrogen. Then the red ball there pertains to your oxygen and H again. So it has a formula of CH3, CH2OH. That is your methanol, ethanol, I mean. Okay. For methanol, we have CH3OH here. So it's a tetrahedral shape. Now, how about the naming of this, the nomenclature? So in the IUPAC, of course, the ending of alcohol is ol, OL. Therefore, it has the same manner in the naming in the alkanes and the alkenes, alkynes. But the exception here is instead of ending with E for alkene, ending with Y and E for the alkynes, it will end with all. The ending all will tell you that the compound is alcohol. Same process, it has that rule. You're going to select the longest carbon chain that contains the OH group as the parent alkane and number it from the end that gives OH as the lower number. Your OH here should be having the lower number. So in numbering the parent chain, the location of the OH group takes precedence over alkyl groups or the aryl groups or the halogens. Okay. That's rule number 1. For rule number 2, change the ending of the parent alkane from E to all. And use number to show the location of your OH. If your OH is at carbon 2, you can have here 2 all. Or you can have 2 butanol, 3 hexanol, like that. For cyclic alcohols, numbering begins at the carbon bearing the OH. Same thing with our benzene derivatives. So your OH here, which is phenyl on top, that will have carbon 1, automatically carbon 1. Then same process, name the substituent, the number of substituent in alphabetical order also. So to derive common names of alcohol, name the alkyl group bonded to OH, then add the word alcohol. Same thing with ethyl alcohol, diba? That is a common name. Isopropyl, but ethyl alcohol could be in the IUPAC, it is ethanol. Then isopropyl alcohol, isopropanol. Okay, that isopropyl alcohol. That's the common name. Okay, so in following the IUPAC names, parentheses, common names of 8 lower weight alcohols. Here, this is the IUPAC name of the 8 with common names. This is ethanol. How many carbons are there in ethanol? There are 2. That is, this is 1 and 2, then OH. So that is ethanol for the IUPAC. For the common name, it is ethyl alcohol. This is 1 propanol. That is 1 that, as I have said, it should start with where your OH is nearest. So this is carbon 1, carbon 2, carbon 3. So it is, where is your OH? It is in carbon 1. So that is 1 propanol or propyl alcohol. If your OH is at carbon 2, it's still propane. Therefore, you are going to name this as 2-propanol or monene ang isopropyl alcohol. Isopropyl alcohol actually is 2-propanol. Your OH is in carbon 2. Then your 1-butanol or butyl alcohol, that is carbon 1, 2, 3, 4. Here, this one, this is carbon 1, 2, that is butanol or butyl alcohol. Then this one, your alcohol is at carbon 2, but there, carbon 1 I mean, but there is methyl at carbon 2. Therefore, that is 2-methyl-1-propanol, and that is the common name of that is isobutyl. There are only 8 of this, which has a common names. And this is tertiary butyl alcohol, or this is carbon 1. This is carbon 1, 2. There is here, carbon 1, 2. Pwede po nga niya, 1, 2, 3. Pwede nga na 1, 2, 3 or 1, 2, 3. Therefore, there is OH. Where is your OH? At carbon 2. But there is still also methyl at carbon 2. That is why it's so called 2-methyl 2, where is your alcohol? At 2, it's propanol, or this is known as tertiary butyl alcohol. And this one is a cyclohexane, but there is an OH here. Therefore, this is cyclohexanol or cyclohexyl alcohol for the common name. So these are the 8 example of alcohol with IUPAC, and at the same time, it's pertaining common name. 8 na sila. So, how are you going to name this? Okay, here. This is, the rule says you are going to write, you are going to choose the carbon 1 nearest to your OH. So, you could not choose this as carbon 1 here. Kaya naman ang OH layo ra. Therefore, that is here. That will be carbon 1, carbon 2, carbon 3, carbon 4. In carbon 4, it has methyl, and it's carbon 5. What is 5? That is, that is pentanol. So, where is it? Write first the name of the substituent. 1, 2, 3, 4. That is 4 ethyl, then 2 pentanol. Okay, here. It's okay. 4 methyl, 2 pentanol. For letter B, okay, it is a cyclohexanol. Here, that's cyclohexanol. But there is methyl as it is being given in the rule. Your OH here, your hydroxyl, if it is a cyclohexane, in a form of a cyclo, the OH here will serve as carbon 1. Therefore, if this is carbon 1, therefore this is carbon 2. So the name of this is 2-methyl cyclohexanol. Okay, so this one is your assignment. Okay, you are going to submit this one by, okay, Friday. You are going to submit this one by Friday as your assignment. But we could classify alcohol also as primary, secondary, tertiary. It will depend on the carbon groups bonded to the carbon bearing the OH. Okay, example. No? So, how are you going to classify this as primary, secondary, and tertiary? Okay. No? So, it will depend. Where is your primary, secondary? Here. No? Solution here, this A here is secondary because your carbon is not, your OH is not directly attached to your, to your link here, to your cyclo here. No? Therefore, it is attached to your carbon. It is secondary alcohol. Okay. This one is tertiary. Why? Because your carbon is being attached into 4. No? Kaupat na siya nga na. That's pila kabuk yang ani. Your carbon here is, it has an attachment wherein naa siya sa nani ang upat. No? This one is attached directly to your, no? This is your methanol. Okay. So this is a primary alcohol. So how are we going to distinguish primary, secondary, tertiary? No? Okay. That is if and when its attachment is directly, your carbon is directly attached to your, actually this one is now your, how are you going to name this? This is methanol. No? But there is 1, 2, 3, 4, 5. There is a cyclopentyl, na, in carbon 1. That is 1 cyclopentyl, then methanol. It's a primary because it is directly attached to your this one. This one is tertiary, this one is secondary. Okay. So you're going to classify here now your alcohol here. If it is, this is again an assignment. If this is a secondary, primary, and tertiary. Okay. In the IUPAC system also, in case there will be 2 hydroxyl group, 2 OH group, or 3 OH group, no, that contains in your structure, for 2 hydroxyl group, you are going to use the diol, meaning there are 2 alcohols. If it has 3 hydroxyl group, you are going to name it as triol, so on and so forth. No? So the IUPAC names of diols, triols, and so on, the final E in the name of the parenthesis alkane is retained. For instance, dili na to butangan ni mong ethanol. Dili na. It's instead ethane diol. Propane triol. Like that. So if and when there is an existence of 2 to 3 hydroxyl group in your given alkane, alkane alcohol. Alcohol with your alkane, the alkane containing OH group with 2 or more OH group. So compounds containing 2 hydroxyl groups on adjacent carbon, if it is adjacent, they are named as glycols. Adjacent, adjacent to hydroxyl group, okay, is diols. Okay, for instance, this one, it is an ethane, but in carbon 1, carbon 2, there is 2 OH. Therefore, all you have to do is 1,2-ethane, because your parent name is ethane, but there are 2 hydroxyl group. Therefore, that is 1,2-ethane diols, or this is known as, the common name is ethylene glycol. Okay. Here, this is carbon, 1, 2. You should not have this as carbon 1, but this one. 1, 2. There is carbon, there is OH in carbon 1. There is OH in carbon 2. That is 1, 2. What is the parent name? It's propane. Therefore, 1,2-propane diol, or propylene glycol. And the last one, example here, there are 3 OH in carbon 1. Pwede rin siya carbon 1, carbon 2, carbon 3. Pwede rin siya carbon 1, 2, 3. Because it has the same connotation. Therefore, that is 1, 2, 3 propane. How many hydroxyl group? 3. It's triol, or this is glycerol or glycerine. Okay, so this is how you are going to use the diols and the triols. Okay. What is ethylene glycol? Ethylene glycol is having 2 OH. That is 1, 2, the common, the IUPAC name of this is 1,2-ethane diol. Here, kani. So this is use. Ethylene glycol is a polar dissolved readily in water, and it is used for cleansing. Cleansing siya. Okay. What are physical properties of alcohol? The most important physical properties of alcohol is its polarity due to the presence of the OH. Because the large difference in electronegativity between oxygen and carbon, and between oxygen and hydrogen, both CO and OH, bonds alcohol, and that is why this makes them polar covalent. So alcohols are polar molecules. Polar molecules na sila. If you talk about polar molecules, the 2 elements in the compound could either be partially positive and partially negative, depending on the electronegativity difference. Asay mas dako. For instance, carbon and oxygen. Carbon and oxygen, carbon mas dako contrast oxygen. Ang oxygen day is mas dako contrast koan, and your carbon will be partially positive, your oxygen will be partially negative, your hydrogen will be partially positive. But the cloud density will be greater in the partial negative oxygen than in hydrogen and oxygen. The partial negative oxygen will have a greater electron density. So the COH bond and methanol, there are partial positive charges on carbon and hydrogen and partial negative charges on oxygen. So an electron density map showing the partial negative charge is in red around the oxygen and partial positive charge in blue around hydrogen of the OH. So mas dako ang electron clouds sa partial sa oxygen compared with the hydrogen. An example of this is the nitroglycine. Nitroglycine is an explosive drug here. That is 1,2,3 propane triol. When it is nitrified, what will happen? This will form into 1,2,3 propane triol trinitrate or nitroglycerin. So that nitroglycerin nowadays is being used as blasting agent. What is blasting agent? Long before, what happened is, we could not connect. We could not connect bridges. So what happened? We could not directly have straight dalan because of the presence of kanang mga mountainous area. So what happened is this is being made into plain by means of blasting. And what is this blasting agent? It is the nitroglycerin. Kanang murag ang gamay-gamay ani is dynamite. Okay. So see, pag blast siyempre mabungkag. Okay. So that is. But this is used for construction of canals, tunnels, roads, mines. Pero ginagamit po ni, of course, during warfare. Pero ang pinaka-problema sa nitroglycerin is it's difficult to handle. Kaya nga naman, dali siya mo init. Pag init niya, mo explode din siya. But this is being controlled by a Swedish chemist, that is Alfred Nobel. Okay, Nobel Prize. Okay, he discovered what happened is this so-called nitroglycerin is a diatomaceous earth. What we call this, and this could be covered by means of a fuse. Kung walay fuse, maunang mahitabo, mo init, mo explode. Pero butangani mo siya fuse, what will happen? What is that fuse? So your dynamite here or your nitroglycerin is being fused or it is being in place in a clay. So kaning nitroglycerin aron dili siya dali mo init, i-cover nimo siya og clay. Like that. So pag cover nimo og clay, dili na siya dali mo init. Bisag at a higher temperature di siya kaya naman it's covered by a clay. But in order that this will blast, it will boom, kinala na siya fuse. Mao na kita as mga dynamite. Dynamite is covered with a clay, di ay na siya. Then naay fuse. The fuse there is katong naay murag dagkutanan. Of course, pag dagkot nimo, what will happen? Pag dagkot nimo, init man siya, musulod nga to, una siya, pag init na sa nitroglycerin, una siya explode. Pero kung di nimo siya dagkotan, dili po siya mobukto. Why? Because this is being covered by most cases a clay-like substance na dili siya dali mo diffuse, di siya dali mo init. Okay, so that is the glycerin, that nitroglycerin. But this has also a medical It has also a medical importance. Okay. And the nitroglycerin in a liquid form could be used in a tablet form or paste form. What is its function? This will relax the smooth muscles of the blood vessel, causing dilation of the coronary artery. So, tendency manggod, kung ang atong coronary is blocked by a blood, what will happen? So, this will not reach, the blood will not reach our heart. Mo nang naadayin siya, cardiac arrest. In order, kaya nga naman, hingdilgate, nadalate. Meaning, hinggamay ang passage sa atong artery, sa atong heart, the blood, the coronary artery. So, kinahanglan i-dilate niya. Dilate meaning, iyang ipa-expound niya, ipadako niya, aron pag-expound mo relax dayon ang smooth muscle, mo flow na dayon, apil ang blood vessel, mo flow na dayon ang blood sa artery, sa coronary artery. Using this nitroglycerin nga in a form of tablet or paste. So, that is one of its benefit. Pero, si Nobel, when he becomes ill of heart disease, his physician already advised him to take nitroglycerin to relieve kaning sa kapingot sa chest. Di ba kung naay coronary heart disease, kanang nighttime musakit ang dughan, kay nga naman murag mo, kay nga naman murag ipiton. That ipiton there is because the artery, the coronary artery is already dili ka sulod ang dili ka flow ang blood. But wala siya musugot. He refused because according to him, dili ito siya para pang gamit sa chest pain, relieve chest pain. Para to siya explosive. It took 100 years before they find the answer. But now, this is already used in a form of nitric oxide, NO, derived from nitro groups, nitroglycerin, which relieves pain. Okay. So, pero namatay siya, wa siya gamit sa iyang discover niya. Ang na-discover lang niya is this nitroglycerin could be, the explosion could be controlled if you're going to pack this or you are going to cover this or absorb this with a clay-like substance. Aron dili siya dali mo init o mo explode. Okay. So that is the nitroglycerin. Kanimo na ni siya karon. Ana, kita ka. So kung dagkutan nimo na nganha, of course, mo init man ilalom, pag init sa ilaw, mo explode. Kilala na siya, okay. So nitroglycerin is more stable when absorbed into inert solids. So what are its inert solids? It's a clay-like substance, like dynamite. That is Alfred Nobel. Okay, so look into this. Let us compare. This is alcohol. This is methanol. This is ethane. Let us look into its molecular weight and its boiling point and solubility. The molecular weight of methanol is 32, while ethane is 30. Pero tanawang boiling point sa methanol, 65, while the boiling point of ethane is negative 89. Its solubility in water, mo ganing methanol na ay 70%, na ay ethyl, bisag ethyl, na ay 70%, na ay 60%, na ay 40%. Meaning, why? Because it is soluble in water. It is infinite. Meaning, pwede mo siya i-dissolve in water. Pero ang ethane insoluble. Same thing with ethanol. So, infinite gihapon. Ethanol o propane, halos pari-pareho ra og molecular weight, pero mo differ gyud sila sa ilang boiling point. Dako ang boiling point sa alcohol. O soluble kaayo siya sa water, asa man magsugod ang insolubility sa alcohol. The more mo taas ang iyang R groups. Take a look. It is butanol. No? Butanol, no? Pila na ka carbon o pat. No? So, take a look. It will have a solubility na ana siya ay range sa solubility 8 grams per 100 grams. No? Pero ang boiling point gyapon niya taas gyapon. No? Compared with pentane nga 72 ang molecular weight, 74 ang butanol, but they will differ in its boiling point. In short, alcohol with almost the same molecular weight with alkane will have a greater boiling point and have a greater solubility in water. Okay, that's it. So alcohols have higher boiling points than do alkanes, alkenes, and alkynes of similar molecular weight because alcohol's molecules, what? It is associated with hydrogen bonding. Because of the hydrogen bonding that makes it more soluble, higher boiling point compared with the alkenes, the alkanes, the alkynes molecule. Okay. And at the same time, also because of the increase in London dispersion forces between larger molecules, the boiling point of all types of compounds, including alcohols, increases with increasing molecular weight. So, duhani ang effect niya nga, no? First is because of the hydrogen bonding. Second is because of the increase in London dispersion force. Okay. So that's hydrogen bonding associated with hydrogen bonding. This is partially positive, that's the hydrogen. Then the oxygen, this is partially negative. Partially negative is the oxygen, partially positive is the hydrogen. The red there is the oxygen, the white there is the hydrogen. So as molecular weight increases, the water solubility of alcohols become more like that of hydrocarbons. So beyond 4, mag-5 na gani ang carbon, no, and the alcohols, what will happen? Become more like hydrocarbons. No? So similar, halos pareho na siya sa molecular weight sa hydrocarbons, basta sobra na sa 4, 5 na, what will happen? It will be less soluble in water, and at the same time, this will decrease also in its boiling point and becomes so large relative to the size of OH. So that is its relevance in the boiling point and the solubility. What are the characteristics of alcohols once it will react? So this is what we are going to discuss. Na? The first one is the acidity of the alcohols. Kani ang mga reactions of alcohols. First one is reaction with the acidity of the alcohols, the dehydration of the alkenes, then the oxidation of aldehydes, ketones, and carboxylic acid. First, the acidity of alcohol. No? So alcohols have the same acidity values with water, pareho siya, no? Which means that aqueous solutions of alcohols have approximately pH as that of the water. So it's neutral, almost neutral. No? It's different with phenols. Phenols, what are phenols? That is a derivative, benzene derivative with OH, diba? That's phenol. That's the benzene ring and the OH, that's phenols. These are weak acids and react with aqueous sodium. It will react with sodium hydroxide, NaOH, to form water-soluble salt. Now, this is our phenol. This is our sodium hydroxide. And what will happen? You will form into a penoxide, sodium penoxide, which is known as a water-soluble salt. That is for phenols. So the second reaction is the acid catalyst dehydration of alcohol. No? What do you mean by dehydration? This is the elimination of water molecule from the alcohol. So in the dehydration of alcohol, your OH is removed from one carbon and H is removed from the adjacent carbon to form into HOH or water. No? Maka-form ka og water from your alcohol. Gikan sa alcohol, ang product is HOH or water. No? That is dehydration. So in the laboratory, dehydration of alcohol is most often brought about heating it with either 85% phosphoric acid or concentrated sulfuric acid, meaning this will aid with this. Yeah? These two are the solvent which is used in order to dehydrate, in the dehydration of alcohol. It could either be phosphoric acid or concentrated sulfuric acid. No? And how are we going to form the primary, the secondary, and the tertiary alcohol? Here. No? So we are still in the dehydration. Okay. How are we going to form the primary alcohol? So if it is ethanol, this is the ethyl alcohol. Dua biya to ha? Sulfuric acid and phosphoric acid. No? So how are we going to eliminate? Diba ingon nga makuha dayon ning OH kaning niya o kani adjacent pud ani. Makuha ang usa ka hydrogen. Okay? So to form your H2O. So kaning niya your one hydrogen will be taken away. Then also this OH here to form into an alcohol. So from an alcohol, you will form an alkene. Alkene. That's the primary alcohol. In the primary alcohol, primary yan siya. So all reactions in primary alcohols, you will form an alkene plus water. Remember that. For the secondary alcohol, kung secondary alcohol po, for instance, the cyclohexanol, okay, with sulfuric acid, you will form also an alkene plus water. Same with hapon. But this one is secondary, meaning this one is in the form of cyclohexanol, sulfuric acid also. Then you will get a cyclohexene. You will also get this OH here, kani, o usa ka hydrogen nga niya. Mo nang mag-double bond na ha. Okay. For the tertiary, tertiary alcohol undergoes acid catalyst dehydration at temperatures slightly above room temperature. Take a look. Asa man ang pinakataas na temperature? It's in the primary alcohol. The conversion of primary alcohol into dehydration or elimination into water. The second is the secondary. This is 180 degrees, 140. In the tertiary, it's only 50 degrees with sulfuric acid. Here, what will happen? Kani ma-remove ni siya ug ang usa ka hydrogen niya to form this into a double bond. Same thing, alkene gihapon. Therefore, this is 2-methyl-2-propanol. You will take this away and this will be double bond here. Therefore, it will be 2-methyl, then it is 2-methyl and 1,2. This is 2-methyl, that is 1-propene. 2-methyl, 1-propene. Okay. Kung ano siya? This should be 2-methyl, 1-propene or the isobutylene. So, which has a higher temperature? If it is primary, followed by 4 dehydration. That's primary, secondary, and tertiary. No? That is it. Then you can see here what is the ease of dehydration of alcohol. Of course, the ease is it's easy to dehydrate what? The primary, going that the is. It's primary, secondary, tertiary. Okay. That's the ease of acid catalysis of dehydration of alcohol. So when the acid catalyst dehydration of alcohol yields isomeric alkenes, the alkene having the greater number of alkyl groups on the double bond generally predominates. For instance, kani 2-butanol, no? Asa man dapit makuha ba ning OH kani, di ba? Pagkuha sa OH, kani makuha ang usa ka hydrogen. Pwede ni siya mo-form into this one, OH. Pwede ni siya mo-form, pwede ni makuha ang hydrogen ani, here. You will form this one, or kani, then kani may makuhaan og hydrogen. What will predominate is the alkene having the greater alkyl groups. Asa may mas dako og alkyl groups? Is it 2-butene or 1-butene? It is 2-butene. Okay, so this will be the major product, this one here. That's the major product. That's 2-butene instead of 1-butene. So you're going to, this is another assignment. You're going to draw the structural formula of alkenes formed by the acid catalyst dehydration of each alcohol here. 3-methyl-2-butanol, then 2-methyl-cyclopentanol. Then you're going to predict the major product. This is your assignment. Oh, di ay. Na di ay. O sige lang, assignment gapon ninyo siya. Okay. Here. Kanina lang. Katong next na lang. So your solution here, that is 3-methyl-2-butanol, kani. So elimination, H2O. So pwede ang carbon, from carbons 2,3 gives 2-methyl-butene, or then elimination of H2O with carbon 1, 2 gives 3-methyl-1-butene. Pero, which will have a greater alkyl groups? Sa 2-methyl-2-butene, pila ka alkyl? There will be 3 methyl groups on the double bond. So this will be the major product compared with 3-methyl-1-butene. Kani. This is it. Kani ang major product compared with this. Okay, mas daghan siya alkyl group here. This one. So that is our solution for B. We have 2-methyl-cyclopentanol by dehydration, the acid catalyst dehydration using sulfuric acid. Of course, this will be taken out. Tapos, pwede kani nga na mag-double bond or kana mag-double bond. Pero asa ang major product? Kani siya, kani. Nga naman, it has only 2. The minor products has 3-methyl-cyclopentene has only 2 alkyl groups. While katong usa has 3. Kani has 3 alkyl groups. Kani has 2 alkyl groups. Amo prevail ang mas daghan og alkyl groups. So this will be your assignment. So we had already studied the acid catalyst hydration. So what happened is an alkenes with balihon. Ang ganina, we have an alcohol with phosphoric and sulfuric acid, you will have dehydration kani na wherein na you will form water. Okay. Bali ni siya. Ngani padulungan no alcohol kani siya. Alcohol na alcohol by means of dehydration, you will come up with a product of an alkene plus water. Bali na pod alkene plus water by hydration. Hydration meaning makuhaan og H2, you will form an alcohol. This is reversible reaction. Okay. So in accordance with Le Chatelier's principle, large amount of water, in other words, using dilute aqueous acid, favor alcohol formation. Whereas scarcity, kung mas dagan ang water, the amount of water, this will favor the formation of alcohol. If it has less water, instead it will be using concentrated acid, where water is removed. What will it favor? It will favor alkene formation. That's it. It's reversible. So this is an example of dehydration of alcohols and hydration of alkenes. That's A and B. So you should propose now which will have a greater product. Is it compound A or compound B? Okay, this is here. Kani. So, kani OH by means of dehydration, what will happen? Kani and this one. Kana, then compound A, then kana, then compound B. So, in the acid catalysis, what will happen? The dehydration of 2-methyl-3-pentanol gives predominantly mas daghan compared with 2-methyl-2-pentene anuman. Ang 3 substitution is on the double bond, while ang usa 2-methyl groups is in one of the ethyl groups. Take a look here. This is 2-methyl this is what this one. 2-methyl-3-butanol, 2-methyl, 1-2, 2-methyl, then 3. This is where your OH. What is your alkane? 1, 2, 3, 1, 2, 3, 4. So it is 1. It's not butane. 1, 2, 3, 4, 5. It's 5. Actually, this is 2-methyl-3 pentanol, not butanol. Okay. Then you will form, it's not butanol, butanol here, right? It's pentanol because there are 1, 2, 3, 4, 5. There are 5 carbons, not 4 carbons. Okay, so it's 2-methyl-3-pentanol. By means of dehydration, you will form 2-methyl, adjacent maguna siya, nga naa ang makuhaan of hydrogen. 2-methyl, then 2-pentene, 1 to 2-pentene. That's the major product instead of this one. This one, it is kani. This is the major product. Instead of having CH3, CH, then double bond, ang ngani pud ang double bond nga usa, it's a minor product. This is the major product. Another example is the catalysis of 2-methyl-pentanol kani. Pentanol na ba po ni? 1, 2, 3, 4, 5. Oh, pentanol gid siya. Anong ganina sayop man to kaniya? Here. So it's here 2-methyl, 1, 2, that's 2-methyl, 2-pentene, 2-methyl, here. This is 2-methyl 2-pentanol. No? So, how it is being formed? By the hydration, balihon, the hydration of this, that is 2-methyl 1, 2, 3, 4, 5, 2-pentene. 2-methyl 2-pentene with the dehydration, no? You will form, by means of hydration, I mean, you will form this compound. Okay. So this will be your assignment. Okay. The next reaction of alcohol is the oxidation of primary and secondary alcohol here. So in the primary alcohol, this can be oxidized. Kung primary alcohol, once it is oxidized, it will form into aldehyde. Then soon it will finally form into carboxylic acid. But it will pass through the process of being converted into aldehyde. No? So the letter O in the bracket over the action arrow indicates that its transformation involves oxidation. Makita gani mo bracket nga O, meaning the transformation there is oxidation. For instance, here, no, your primary alcohol, no, once it is oxidized, as I've said, this will lead into aldehyde. Further oxidation will yield into carboxylic acid. First, as a primary alcohol, once it is oxidized, this will come first into the transformation of aldehyde, then further oxidation of this will transform into carboxylic acid. So there will be two products, but the main product of this in the primary and secondary alcohol is the carboxylic acid. It's different with the tertiary, later in a nutshell. So mostly the reagent that is being used in the laboratory for the primary alcohol, basta primary alcohol to carboxylic acid is the potassium dichromate. That is K2Cr2O7. And it is dissolved in sulfuric acid. Now, this reagent oxidation will, for instance, in 1-octanol, it will yield into octanoic acid. Okay, from alcohol, primary alcohol, to carboxylic acid. Here, that is 1-octanol, 1-octanol with the reagent that is potassium dichromate and sulfuric acid. First, it will lead into what? An aldehyde. Further oxidation of this will lead into an acid. So, 1-octanol oxidized. First, it will have the first product, an aldehyde octanol. Then further oxidation of this will lead into carboxylic acid, which is octanoic acid. This is the third reaction. So although the usual product of oxidation of primary alcohol is carboxylic acid, it's often possible to stop oxidation at the aldehyde stage. Before mo proceed na siya into a product of carboxylic acid, it will first have the stage of transformation that into an aldehyde. Okay, so that is its process. How about secondary? That is for the primary pa to. Basta primary gani, oxidize. What is its reagent? That is potassium dichromate with sulfuric acid. Its first oxidation step will lead into aldehyde, and the second oxidation step will lead into carboxylic acid for the primary alcohols. For the secondary alcohol, okay, once it is oxidized, it will turn into ketones. Lahi siya ha? It will turn into ketones. What is the oxidizing agent? Same thing. It is the potassium dichromate. Example of this. This is the this one. That ring there, that is the 2-isopropyl 5-methyl cyclohexanol. This is the menthol. With the oxidizing agent, because this is the secondary alcohol, this will be converted into a ketone. That is 2-isopropyl 5-methyl cyclohexanone. Okay, that's it. That's for the secondary. So menthol, a secondary alcohol present in the peppermint, no? And other mint oils is used in the lacquers. Mga thinner bitaw, thinner lacquers, dami kay sila baho, no? Because of the menthol. In the cigarette, kanang pag-puff sa cigarette, humot siya menthol. Okay. Even in the cough syrup, di ba? Cough syrup na po siya menthol. No? In the perfumes. And labaw na sa mga inhalers na siya menthol. That is its use. So, its oxidation, the process, there is oxidation. Oxidation product of the menthol. Okay. So, for example, here, we have 1-hexanol, this one. 1-hexanol, this is primary alcohol. Diba? Primary alcohol. This will lead into hexanal. Then after hexanal, it will be in hexanoic acid. This is a primary. How about for B? It's a secondary. Because it's a secondary, this will lead into a ketone. Your product will be 2-hexanone. So that's the difference between the reaction of a primary alcohol, which will lead into aldehyde and finally into carboxylic acid. But for the secondary alcohol, it will lead into a ketone. Okay, that's the difference between its product. So here is another assignment, no? The cyclohexanol and the 2-pentanol. No? One example of this reaction is the breath alcohol screening. What is breath alcohol screening? Kinesia is being used in order to track down, no, drivers who are driving under the influence of alcohol. Okay, no? Nganis ato kay simhot-simhot system man. You are influenced. You are under the influence of alcohol. Pero sa states at the same time in a highly progressive countries, they are using the breath alcohol screening. What is this breath alcohol screening? So what happened is, kani, mo ni siya. It is in a glass tube. It contains this portion here. It's a glass tube. It contains here a potassium dichromate and sulfuric. Di ba mauni ang iyang? Di ba mauni ang reagent? It's potassium dichromate and sulfuric. No? This is a coated silica gel. Okay. No? Ang person na under the influence or you want to test it, imo mo ni siyang ipa-blow ngania sa kaning glass tubing. Okay. So, because, di ba, sa iyang breath, di ba, naamay, simhot man nato ang alcohol. Okay. Katong alcohol content nga ngadto sa iyang gibuga, no? This will react with potassium dichromate and sulfuric acid. So as the person blows, what will happen? So this plastic bag here kanang murag pag buga niya, syempre kana siya murabag balloon. Okay. Mo inflate pod, mudako, no? Pag inflate ana kay hibuga man siya og hangin, no? Then afterwards mo hinahinay naghuyos. Pag hinahinay huyos, katong iyang gibugang na ay gaseous, no? Gaseous kay hangin man, gaseous substance nga na ay alcohol. This will now gives off a color. Okay, here. It will react with your potassium dichromate and sulfuric acid. Okay. And this will give a Kani an orangey color, no? So ma-determine po nila kani ana siya gauge, ana siya call this. The other term for that is it has its na siya readings nga naa, no? So mabalaan unsa kataas or kaubos or wala ka mag-inom. Kinahanglan it should be, no, dili maugmaan. Kaya kung maugmaan, siyempre, the concentration of the alcohol will already deplete. Kana siya. It is, what is this? This is the breath alcohol screening. Ha? So, the breath alcohol, it has an research that 2,100 ml of breath contains the same amount of ethanol in the blood. Okay. So, mabalaan mo, the more manggod, ang tolerance po noon sa tao sa alcohol, it will depend. Magdepende siya. Pero makit-an gihapon siya sa, makuha gihapon siya sa breath alcohol screening. E kanang tolerance sa alcohol kanang dali mahubog, magdepende po na sa tao. Pero, ang alcohol content sa imong blood, ma-determine yun siya. Okay, so, mabalaan ang tao if it is under the influence of alcohol at a maximum level, the medium, and less. Okay, that's it. By means of breath alcohol screening. Okay. So what are the structure names of properties? We are now finished with alcohols. Let us proceed to the ethers. What ethers? What are ethers? Ethers are compound containing oxygen atom bonded to two atoms carbon atoms bonded to two carbon atoms. Kani? This is your oxygen bonded to two carbon atoms. Okay, this is the methyl. So, duha ka methyl, therefore that is dimethyl ether. Ngalan ana. Is dimethyl ether. That is the ball and stick model. How are we going to name the ether? It's easy. As I have said, the functional group 1 here, the R1, then the another, no, not functional, but the alkyl group 1 here, the R1, then the other alkyl in 2, no? That is, common names are derived by listing the alkyl groups bonded to the oxygen in alphabetical order and adding the word ether. So kung ang niya is ethyl, ang nganto as methyl, unsa may atong unahon? It is ethyl methyl ether, like this, no? Alternatively, one of the groups on the oxygen is named as pwede po og alkoxy group, no? The OC3 pwede ra group, for example, is named as methoxy to indicate the methyl group katong with O and the alkyl group bonded with oxygen. So, pwede na ni siya og diethyl kani. Diethyl ether. Kani, this is the cyclohexyl, then this is the methyl ether. Na? That is cyclohexyl, methyl, then ether. Alphabetical. This is cyclo. This is methyl. Na? So that is cyclohexyl methyl ether. Or you can name this kanimo ay methoxy, and this is cyclohexane. So methoxy cyclohexane. But it's quite easy to have it one at a time. Kani, alphabetical lang. That is the cyclohexyl. And the other one is the methyl. And this is O here is the ether. So let us name this. Okay. This is, kani, what is this? Diba? This is tertiary butyl. Kani is ethyl. Asa may una? Na? Tertiary butyl. Unahon itong butyl. Na? Butyl. That is, ayun apila ang third. Na? Pero kaning third, it could not be included in the alphabetical. It is the butyl. So that is tertiary butyl, and this is ethyl ether. Kani, duha ka phenyl, na? Or duha ka cyclohexyl. So you can name this as 2-cyclohexyl ether. Or diphenyl, pwede pa siya, diphenyl ether. So that's the name of the ethers. So you are going to have this as your assignment. What is one of the application of the ether? It is in the ethylene oxide. This is a chemical sterilant. What do you mean by chemical sterilant? This is used, no? This is used as, this ethylene oxide are used as fumigants in foodstuffs. Fumigants meaning na mga pagkaon nga mamangon, no? In order that this will not mamang, no? There is that spray nila, that spray is containing with ethylene oxide for fumigants in foodstuff and even in textile. No? It's used also in the hospital to sterilize surgical instruments. So this ethylene oxide, which is in a form of ether, has these uses. No? First is fumigant in foodstuffs. Then it will also be needed in textiles. Aron dili mamangon, no? And also a sterilizer in the surgical instrument. That is ethylene oxide. No? Cyclic ether, which that is the ethylene oxide and the katong na i-convert na into furan, that is tetrahydrofuran, THF. What are its physical properties of ethers? So ethers are popular compounds in which oxygen bears a partial negative charge and each attached carbon bears a partial positive charge. No? Katong na ay oxygen has a partial na negative. Katong yung attached sa pikas is having a partial positive. No? So that's it. Take a look. So this is one has a partial positive, kani, a partial positive. This one has the partial negative. Okay. So ethers are good for anesthesia also. No? What is anesthesia? Actually, this is being used way back, no? But medyo baguhay na balaan, no? So, this is during Joseph Presley wherein he isolated nitrous oxide at N2O2. This is a colorless gas, okay? No? Known as laughing gas kay baho. Basta once makapanimaho ka ani, di nakamuundang og sige katawa. That is so-called laughing gas. No? This was first used by an American dentist, Horace Wells, as anesthesia. Pero ang nahitabo, no, for general practice, pag ibot niya, gamay ra nga dosage ang iyang nabutang, ang nahitabo, wala katulog ang patient. No? So, pag mata sa patient, no, siyempre, pag ibot niyo perting sakita. And that patient died during the procedure. O ang nahitabo, hinghawa si sa practice, no? Medical practice, and later on, he committed suicide at the age of 33. Kaya di niya madawat. No? But it was Charles Jackson who uses this as anesthesia. Again, no? Gigamit niya siyang kaugalingon. Using now not the nitrous oxide, he is using the diethyl ether, which is being, he persuade a dentist named William Morton na testing ako no gamitan ni siya. Pero nahadlok daw, this dentist is afraid because of what happened to Humphrey Davy. He still uses this, as anesthesia during operation. But what happened here is it gives a positive result. No? So, may nalang gani kay gibalik niya. Pero taas-taas na siguro dosage. No? So, the operation was completely successful and soon general anesthesia by diethyl ether becomes routine practice for general surgery. But there are setbacks also. What are its side effects, no? Nga naman, this diethyl ether was easy to use and cost excellent. It will relax the muscle. Pag relax sa muscle, makatuog ng tao, okay. So, mawa na dayon ang pain. So, the blood pressure, pulse rate, and respiration, usually, it will only affect slightly. Pero nowadays, until now, those who have a heart failure, no, lisod gyud sila tagaan og anesthesia. That is why it's difficult for them to undergo katong na mga heart, no, heart problem. It's difficult for them to undergo operation because though, no, it will affect slightly pero basig na sila ka mata. Mo nang careful gyud ang mga doctors, mga surgeons in the application of this anesthesia if and when the person has a history of, no, heart disease, no? So, napoy anesthesia nga inhalation lang, no? Inhalation lang. Parang simhot-simhot kung minor lang nga what you call this? Surgery, no? Pero kung major surgery, it should be injected by means of the diethyl ether. No? Ang drawback lang niya is, unsa may mga after effect niya, it will have irritating, no, effect in the respiratory and it could cause sometimes nausea. Maka-cause og kanang nausea meaning vomiting. Okay, so that's it. That is an ether and anesthesia. So it is in a form of diethyl ether, no? Kita na mo kabalo mo diethyl ether, no? CH3, CH2, then O, then CH2, CH3. That is the formula of diethyl ethers. Okay. Let us compare now ethanol and diethyl ether. Ethanol will have a boiling point of 78 while diethyl ether has negative 24. Nga naman, because kanina ay OH, which will have a hydrogen bonding. Okay. Kani walay formation sa hydrogen bonding. Wala, no? That is why it will have a very, very low boiling point. Okay. So ethers are more soluble in water than hydrocarbons. Pero kung i-compare mo siya sa hydrocarbon o ether, mas okay pa ang ether, no? With similar weight, but less soluble than isomeric alcohols. Dili gud siya pwede ka-feel this alcohol because alcohol has a hydrogen bonding. No? Okay. So the reaction of ethers resembles with hydrocarbons in the resistance to chemical reaction. So not that much reactive. So they do not react with oxidizing agent such as potassium dichromate. Likewise, they do not react with reducing agents, no, such as H2 as metal catalyst. Furthermore, most acid and bases at moderate temperatures do not affect them. So ethers are mostly unreactive, no? Halos pareho sila hydrocarbons. Because of their general inertness to chemical reaction, their good solvent properties, ethers are excellent solvent in which to carry out many organic reactions. So they are good solvent for organic compounds also. No? Example of this is the most important ether is solvent is the diethyl ether. Tas brato pa yun ang solvent nga diethyl ether. So, we are now in the thiols. Humana ta sa ether. What are the structure of thiols? It has HS. Na? A compound that contains SH, or the sulfhydryl groups, bonded to tetrahedral carbon, like that. Na? Okay, here. So, this is, di ba, this is methane, and this is thiol. So, yun kayo pagpangalan. Methane thiol. No? Kung ethane na, ethane thiol. Like that. Na? So, the nomenclature, sulfur analog of alcohol are called thiols. No? Thi from the Greek word theon, then sulfur, or in the older literature, panagsatawag ana mercaptan, which literally means mercury capturing, mercaptan. So the IUPAC system, thiols are named by selecting the longest carbon chain that contains the SH group as the parent alkane. To show that the compound is thiol, we add the suffix thiol. So it's easy, thiol. To the name of the parent alkane, the parent chain is numbered in the direction that gives the SH group of the lower carbon. So here is an example. This is ethyl, then this is thiol, or ethane thiol, or ethyl, then mercaptan. Then here is your SH. But the branching here is 2. Pwede lang na, that's 1, 1, 2. No? So, kani ang 1. No? Ngani kang 1. 1, 2, 3. No? So, where is our HS? It is in 1. What is the parent name? Is the propane. But there is a branching at carbon 2 with methyl. So that's 2 methyl. Where is your HS? Is in 1. Therefore, the name of that is 2 methyl 1 propane thiol, or that is the isobutyl mercaptan for the common name. Another example here. This is 1, 2, 3, 4. Not a solution. Basic Y solution. That's 1, 2, 3, 4, 5. It's 5. No? Therefore, that is pentane. No? That is 1. No? Pwede na pupunta. 1 pentane thiol. Or it's already understood as pentane thiol. Okay. Or in the common name, that is pentyl mercaptan. Kani? This is carbon 1, 2, 3, 4. Oh, it is, where is your SH? In 2. Therefore, that is 2, no, butane thiol. That's the name of this. That is 2-butane thiol, or the sec-butyl mercaptan for the common name. This is your assignment. You're going to write the name of this. No? Of that, kani. The most notable property of low molecular weight thiols is their stench. Ang ilang baho. Stench. The baho. They are responsible for the unpleasant odors such as for the sunk. The sunk. Rotten egg. Rotten egg ka nang nabugok ng itlog. Sunk. Murag diwa kayo ni sa ato. No? Ano bitong ang iyang mga hair, anak manindog? Oh, wala ni sa ato. Social ni sila. Then, the sewage. Sewage is kanang baho ba sa baho ba sa mga naa sa tayani, kanang nga dugay na nga naa sa kanal, that's sewage. Okay. The set of sunk is due to the primary 2 thiols. What are these? That is 2 thiols. That is that 2-butene 1 thiol, mo nang naa sa sunk, and 3-methyl 1-butyl thiol. No? Kani. It's the sunk. No? Naa sa Sonoran Desert sa America, South America. So, what again is ato social na siya. No? So, ang baho ani, no, is because of these 2 thiols. Kung saan nga thiol, that is the 2-butene 1 thiol of the 3-methyl butene thiol. Okay, what are its physical properties? Because of the small difference in the electronegativity, that is, your sulfur has an electronegativity of 2.5, your hydrogen 2.1. Subtract that one is 0.4. Diba? It is between the bracket of a non-polar covalent. Na? They lack polarity. So thiols show little association with hydrogen bonding. Di yun siya. No? Makig-abi-abi sa hydrogen bonding. So consequently, they have lower boiling points and are less soluble in water and other polar solvents than are solvents similar to molecule. If it is ethane thiol pila, it is 35. This one is dimethyl sulfide. Oh, mas gamay siya. The reaction of the thiols. So thiols are weak acids. So lower than 6. Yeah. That are comparable, no? 'Di ba ang phenols that has a pH of 6 and 6 ranges to 8. So it's less acidic. It is slightly acidic and slightly acidic and slightly basic. Na? So thiols react with strong bases such as sodium hydroxide to form thiolate salt. Ang sa phenol pod, it reacts with sodium hydroxide to form sodium henoxide. Na? Okay, here. That is ethane thiol with sodium. Pariro gyapon. It's sodium phenoxide. Kani sodium ethane thiolate. Okay, that is for this. If you look into the boiling point of the thiols, compared it with alcohol, layo ra siya. Nga naman, because of they don't react with hydrogen. And there is no such thing as hydrogen bonding here in your thiols. Okay. So the most common reaction of thiols in biological system is their oxidation as disulfides. No? Disulfides. So thiols are readily oxidized as disulfides and susceptible to oxidation, and they must be protected kidali siya ma-dissolve, no? Protected in contact with air during storage. Okay. Disulfides in turn are easily reduced to thiols by several reducing agents. So this is a thiol, no? Thiol, by means of oxidation, it will form into disulfide. By means of reduction, it will go back as thiols. What are the importance of thiols? No? Most commercial important of alcohols. No? For alcohols first, they derive almost entirely from petroleum. Mga alcohol, di ba? We have the isopropyl alcohol. Where do we get it? Isopropyl alcohol is a byproduct of this petroleum, or for natural gas, we have the ethyl alcohol or coal. Second, many themselves starting materials for the synthesis in commercial product. That is for importance of alcohol. Methanol, which is derived from the wood alcohol. No? Today, methanol is used in the catalytic reduction of the carbon monoxide. No? So methanol, in turn, is the starting material for most of the industrial commercial chemicals, such as the acetic acid and the formaldehyde. What are formaldehyde? These are formalin. Formalin is very important, especially in preservative, preservation of dead bodies. That is formalin. Yeah. Pero ang uban kay ginabutang namal dito ning uban, no? Labaw na ka na mga first class nga bulad. Okay, yala ka. First class nga mga bulad katong madagko what they did. Ang uban kay butangan nila formalin aron tiskig yun ang ang bulad. That is why as much as possible I don't I am not fond of eating those first class bulad nga dagko. Why? Because wa ta kabalo, no? Tiskig unya na siya because of formalin. Mura po imbalsamar. Okay, now that is the coal or the methane by means of oxidation. Basta O gani, parenthesis, that is oxidation. It will be converted in carbon monoxide then by means of the getting off is the hydration, the H2, it will form into methanol. And this methanol, once added with carbon dioxide, will form acetic acid. And the other one, once it will have an oxidation reaction, it will come up with a product of formaldehyde. So that is how important methanol is, because in most of the industrial process, we need acetic acid and formaldehyde. Okay, that's it. So the bulk of ethanol produced worldwide is prepared by acid catalyst. Acid catalyzed hydration of ethylene by means of cracking of ethane from natural gas. So ethanol is also produced by the fermentation of carbohydrates coming from the plant material. The jatropha, di ba? Okay. That is particularly pwede po sa corn and molasses. Corn and molasses. Molasses is the sugar cane. Yeah. So the majority of the fermentation derived ethanol as oxygenate, additive to produce this blend type of ethanol in gasoline. So most of our gasoline nowadays is biofuel, meaning it has an add-on. Pero di pa kay dako, add-on of 20% bioethanol, like that. So here it is. Our ethylene, by means of hydration, you have come up with ethanol, then ethanol to diethyl ether. Pero ang the other one, this ethylene with the catalyst, by means of oxidation, you will form ethylene oxide, then you will form an ethylene glycol. So the acid catalyst dehydration of ethanol gives diethyl ether, which is an important solvent in the industry. Ethylene is also starting material for the preparation of ethylene oxide, which is used in most industry also. So rather, ethylene oxide is important, derives from its role and intermediate production of ethylene glycol, a major component of the automobile antifreeze. Kanang ginabutang sa aron dili mag-overheat ang engine sa automobile, and that is known as automobile antifreeze. And most of we are having so much automobiles nowadays, so this is very important, that ethylene glycol as automobile antifreeze, and this will also lessen the anti-knocking, kana magtingog bitaw ng makina. Yeah, okay. So what happened here, if you are going to have this as coolant in your automobile, instead of boiling to 199 degrees, ethylene glycol freezes at negative 212 and boils at 199, which will make this ideal for the purpose of lowering the automobile, so that it will not freeze, and at the same time it will anti-freeze, at the same time it will not overheat. What are isopropyl alcohol? So what are these important? The diethyl ether, the ethylene oxide, the ethylene glycol. Then you have the isopropyl. Isopropyl alcohol are rubbing alcohol. They are used as disinfectant. These are produced by acid catalysis hydration of the propene. Another one is the glycerin. Glycerin is a byproduct of manufacture of soap by saponification and the animal fats. Without this glycerin, what will happen? Okay, we could not make use of different types of soap. For instance, di ba nabi, lain-lain ang kuan, soap, no? Na ay softener, we can have it as bleaching. Okay, we can have bath soap like that, no? That is an animal soap, no? Animal fat, I mean, added with glycerin. Okay, here it is. That is it. It comes from the the isopropyl comes from the propene. It is by means of the acid catalysis which will have produced tara makadaghan ang iyang product. First step is the epichlorohydrin, which we'll use as epoxy or glues and resins. What are resins? Kanang mga kanang mga plywood, kinahala na siya o resin. Resin is the one which is being add on in order nga mupilit siya kanang sa plywood. So, that is siya ka-importante. Another is, one product of this, that propene is the isopropyl alcohol, and the last one is the glycerin. That's for propene. Okay, that ends our lesson in the three functional group, that is alcohol, which has a derivative of the thiols, and at the same time, derivative of the ester. So, that ends our lecture in about alcohols, ethers, and thiols. So have a pleasant day, everyone, and I will be uploading your assignment in our LMS. Thank you for listening, and a pleasant afternoon. Goodbye.